Chapter 4, Lesson 3 is going to start our work on functions. Let's begin by looking at the vocabulary. First, a function is a relation in which every member of the domain is paired with exactly one member of the range. Now, recall in our previous lesson that a relation is a set or a list of ordered pairs. Our domain was our x values, and the range was the y values. What might be easier to understand is that a function is when every time I plug in an x into the equation, I get exactly one answer. So every time I plug in a number from the domain, I get exactly one number into the range. To look at that, it sometimes helps to look at a function table, which is a way that we organize into a table the input, so what we're plugging in, the rule, which is what operation or operations we're going to be doing, and then the output, which is our final answer. Two terms you should be familiar with. First is independent variable, which is the variable for the domain, which we're going to pick any number we want. So remember, domain is the x, which means we're going to pick our own x values as we go so that we can find the dependent variable, the variable for the range, which is y, and that depends on whatever numbers are in our range depends on what we plugged in from the domain. Think about this in terms of science, where an independent variable is the thing you have control over. Your control is the fact that you're going to be able to pick any number you want to plug in for certain problems. But your answer depends on whichever number you plug in. Let's take a look at what notations we use for functions, because it's going to change from what you might be used to. So we have what's called function notation, where we have f parentheses x equals 15x. Let's talk about how we actually read that. This says f of x equals 15x. F of x equals 15x. Expanding it out further, what this really means is that the function in terms of x, meaning the thing that's changing, is 15 times x. Connecting it back to our vocabulary, the 15 times x, that is our rule that we're going to use. So it's whatever operations we're being asked to do. So f of x equals 15x. We've got to make sure we're saying that the right way. Now let's move on to examples on how we use this function notation. Our first example asks us to find f of -3 if f of x equals 2x plus 1. So what I want to know is, what does the function equal if I plug in -3. So this -3 is going to go inside where I see the x's. So I'm going to write the following. F of -3 equals 2 times -3 plus 1. I want you to look at what has been replaced, what I substituted. When finding f of -3, I'm going to substitute that -3 into the function anywhere I see the variable. Once you do that, we're actually going to simplify this down until I get a single number answer. Well, we know 2 times -3 is -6. I have my plus 1. And then for our final step, f of -3 equals -5. Because -6 plus 1 is -5. That's how quick it can go. As long as you guys are comfortable with your math facts or functioning the calculator, you should be able to plug in the number and find your answer in few steps. For those of you that prefer it, let me go ahead and give you our formal steps. We write the function with the number substituted in. That was this step here, step 1. Step 2, solve. Step 3, simplify. That's all that took place in the rest of the problem. Let us go ahead and take a look at a second example of a problem like this. This one asks to find f of 2 if f of x equals x minus 4. So the function in terms of x is x minus 4. But now I'm asked to find what does my function equal if I put into it the 2. So let's go ahead and substitute that in. I'm going to say f of 2, so the function at 2 equals, instead of x, I'm going to substitute it for 2, minus 4. And now I just need to go ahead and simplify and solve what I can. So f of 2 equals -2. All we are doing is taking what we have and plugging it in. We're going to expand this a little further. I want to show you guys what a function table looks like so that you are familiar with how to fill in the missing pieces. So a function table is a table just like the ones we used in the previous lesson. But this time, it's going to be broken into 3 parts. I have my domain, I have my rule, and then I have my range. In order to use this, we're going to need to pick some numbers for our domain. We're going to need to pick out some x's. You can use any number you want. I'm going to use what is traditionally the at least 4 numbers you're asked to do. Let us use -1, 0, 1, and 2. What you need to now do is to go in and use the function to find out what the range is for those domains. So in the middle, I want to know, well, f of -1. So I'm going to say that instead of x plus 5, it's -1 plus 5, which at the end equals 4. Now, you will not need to write this part. I just wanted to connect it back to what we were doing. All you need to do is write whatever it is we are substituting. So next, instead of saying x plus 5, I'm going to say 0 plus 5, which is 5. Next, I'm going to say 1 plus 5, which is 6. And 2 plus 5, which equals 7. So for this table, we have our domain, our function, and our range. For those of you that might want it, let us go ahead and reveal the formal steps. You're going to need to pick at least 4 x values, and then follow the steps from the previous examples of plugging it in, solving it, and simplifying everything that's possible. Now I would like to move on to an example of a word problem, where I'm going to ask you to read a problem. We're going to identify what's happening in terms of independent and dependent variable. We're going to explore what the domain and range is, and then we're actually going to write the function. So here we go. Here is our example. There are approximately 770 peanuts in a jar of peanut butter. The total number of peanuts, P of j, is a function of the number of jars of peanut butter purchased, j. So it's told us a few things. J represents number of jars. And we already have our function, or at least what we're calling it, P of j. So let's analyze the situation and start by finding independent and dependent variables. It's the first thing we're asked. Independent variable. What is the part that you get to choose? You get to decide. That's going to be the number of jars of peanut butter. Another way of identifying that was when they told us P of j, it told us that j was my domain, and the independent variable is always the values of the domain. For the dependent variable, that is going to be exactly what it says here, the total number of peanuts. So when they describe for us the function, they generally tell us what each piece is before we get started. It told us that the number of peanuts was equal or was found through the function when we plug in the number of jars. Now let's talk about domain and range. because with the domain and range, previously, you could just put a list of numbers. But for this example, that's not going to be the case, because you're not going to want to list out all these numbers. Here's what I want you to consider. With jars of peanut butters, if I'm going to look at my list of real numbers, which has negatives and 0 and positives, am I going to have any negative jars of peanut butter? I will not. But I could have anywhere from, well, 0 jars of peanut butter up to infinite jars of peanut butter. So what I'm going to say is that my domain is going to be the set of all whole numbers. Now, the reason why I said whole numbers is because we're not talking about half jars of peanut butter or 3/4 of a jar of peanut butter. We're talking simply about whole jars of peanut butter. So I'm going to say that the domain is all the whole numbers. Now for the range. I want to try to generalize the range. And by generalize, I mean I don't want to make a list of numbers again, because I could list out an infinite number in terms of the peanuts, starting at 770. I really don't want to have to do that. So what's going to happen is we can describe the range as multiples, so any number that I get by multiplying it to, so it's multiples of 770. So whatever I can multiply to 770, all that's going to end up being my range. So that's 770. If you multiply it by 2, I get 154. 1,540. I apologize. And so on. But we're not going to worry about listing all of that. We're just going to write multiples of 770. Now, in terms of writing the function, they told us that the function written as P of J, what we need to say is, what is it equal to? Well, we've already described it when we talk about the range. We said that it was multiples of 770. That means I'm going to need to multiply. So I'm going to need to multiply 770 by my number of jars. Well, number of jars was represented by J. So this is what is involved right now with our functions chapter. We talked about plugging numbers into a function to get a single answer. We've plugged in numbers into functions to find a range of numbers. And now we've discussed how to look at a real-world example and break down its independent variable, its dependent variable, its entire range, and how to write the function.